Okay, students, very warm welcome to your next session. Today's session could be tricky for some, could be easy for some.
Good morning, sir.
Very good morning. So, hmm, make sure that if you have any questions with respect to aircraft correction, earth magnetism, force of directivity, what pole color matches what pole, a little bit about deviation, horizontal, vertical. See if you have any questions, discuss them right now. Whatever fundamentals that we learn, whatever whatever basics that we learn, it's very important that we master those basics. Only then can we expect ourselves to have 100% scores with respect to any topic. Now, this is something that I keep talking about. This is something that you need to be aware about all the time. This is the reason why I keep talking about it. What happens is generally we hear something, we like it. Okay, good. But how do we make sure are we applying it or not? Whatever strategies that we have. So for that purpose, we realize that we need to repeat it again and again so that you're reminded again and again and automatically it stores in your mind. So make sure you have any questions you ask right now. You can put it in the chat box. So we are continuing learning about magnetism. In the first two segments of learning magnetism of Earth and aircraft, we have seen a lot of things. We have not just seen Earth's magnetism, but we have understood the basic fundamentals of natural magnetism, I could say, wherein it is definitely influenced by the Earth's magnetic field, whatever magnets we use with respect to our compass. But also, what is the other thing? The laws of magnetic field force strength with respect to two magnets and attraction and repulsion, plus strength of the magnets, plus hard iron and soft iron. Hard iron is a material that is difficult to magnetize. Once magnetized, it is permanent. Soft iron magnetism is easy to magnetize, but loses its magnetic property as soon as the magnetizing force is removed. There could be materials existing between the properties of hard iron and soft iron, and they're called as semi-permanent magnets, semi, however you want to call it. Today's topic considers with respect to the same elements of the Earth's magnetism, magnetic field, force, total field force. There are two keywords, flux intensity, magnetic flux. It just means nothing but the entire Earth's magnetic field force. Flux is generally used with magnetism to denote the magnetic field. And the second thing that you will have will be second thing that you'll have, what will it be? It will be magnetic meridian. So you remember there is one line we spoke about magnetic meridian when showing horizontal, vertical, and total. So total is where the dip will happen. The angle between the total force and the horizontal is the dip angle. Don't confuse it with horizontal and vertical component. Give me dip angle. So that magnetic meridian can also be referred in your questions. So you be very simply aware about these things and choose your right options. Okay. I'm hoping to sum up this particular topic today, but it doesn't mean your job is over. You should do some further reading. If you need some study notes, you should request for that also. Okay. So you see lecture 40, lecture 41, and 42 of these series are talking about magnetism, Earth's magnetism, a very simple yet important topic to learn. Today, I'll show you a couple of more pictures. I'll show you a couple of pictures about the two widely used magnetic compasses. One of them is one that we don't use anymore, and one is that we generally use. Just one picture, not much right now. Right now, I want you to use your imagination and mainly focus upon the theory. So you also have to go across the formulas, especially that formula. Tan dip is equal to Z upon H. What is Z? Z is the vertical force or vertical component, and H is the horizontal component. So itself, you see that the dip angle is directly proportional to the vertical component and inversely proportional to the horizontal component. So questions are like that, students. So you have to be very well aware. Anyone who has questions on these points, please let me know right now,
Sir,
and then I'll get started. Please go ahead.
sir, we have seen formulas. One of them is total force square equals to h square plus z square. What does that mean? Could you please elaborate those formulas? Last two formula.
Nukul, sorry. What is the meaning of T and what is the meaning of H and what is the meaning of Z?
Sir, T is a we have a total force, H horizontal force, and vertical force.
Hmm. So, what is the formula saying?
So square of total force equals to horizontal square of horizontal force plus square of vertical force.
Hmm. Hmm. Hmm.
So where we apply this formula, for what reason it's formula for? The rest of the formulas we understand that they used to find out dip angle or vertical force or horizontal
It could
force.
be a combination of everything, you know. They could tell you that the value of T is this and the value of H is this. Find out the value of Z. If you have to use, if you have a question like that, then this is the only formula where you will get either H or Z or T without the dip angle. But the answers are in squares. So whatever value you will get, you will have to square it first using the scientific calci. Square and square, put it in the formula. Whatever answer you get, you make a square root of that answer to get your H or Z or T. Simple. Write down one line. Okay. Mm, write down one line in this regard. Yeah. Relationship between H, Z, and T. Relationship between H, Z, and T can be determined or be understood with a right angle triangle. So all these formulas that we have are basically formulas related to right angle triangle. T square, H square, Z square is nothing but the hypotenuse formula. T is the hypotenuse. Anybody who is aware, this is for them. So hypotenuse square is one side square plus the other side square. So that is the derivation here. It is just to make understanding of how to find values. A collection of all these formulas are not really available in one place. You guys are very lucky that you have it right now. Be sure about it and try to use your logic. Nukul, have you understood the impact or the application of this formula?
Yes, sir.
So students, learning about concepts and having clarity on fundamentals is just one thing to clear exams. Trying to understand the question carefully and using your logic. When I say logic, logic will mean you look at the different parts of the question, go back into your memory, your mind, your treasure trove of your notes, of your learning, then connect the dots, compare with what you know, what is asked in the question. Half of the questions will be direct answers for you, but half of the questions will not be direct answers for you. So scoring 50 is a piece of, is like slicing a piece of cake, we say. It's very easy. But scoring above that is very difficult because it requires logical reasoning. And logical reasoning is like in our Indian thing, we have a saying, right? I can eat something directly, The exam questions will make you eat like this twice, and then give you the food in your mouth. So that's how you get answers. The good thing is, if you know formulas, you can reverse calculate certain questions. I'll give you these exam techniques. I keep giving it. So when you don't know the answer, you can take every option as an answer and reverse calculate and see which values from the question are you getting. This is a very easy way to answer questions that you have never learned, but you need to know some fundamentals which you know. You have to apply that. You have to force your mind to think about it and then apply it. If you don't do, then you'll end up doing silly mistakes and you'll struggle between 65 to 68. That's the difference. If you do it, you'll easily score 80, 85 minimum. I cannot emphasize more than this, students. The more I talk about these things again and again, the lesser time we'll have to talk about concepts. But it doesn't mean these are not important. So, fundamentals, learning concepts is one thing. Second thing is using logic, being smart, which I'm trying to induce in everyone. Most of you all can do it on your own along with my strategies, or use my strategies first and then do your own strategies also. So, this is a part of training that you should take. Does anybody know why we call it Friday the 13th as a bad date, bad luck date? Anybody aware? Today's 13th, the Friday, and it's generally considered as,
Sir, it is considered unlucky, sir. Many
yeah,
hotels
yeah.
also don't have 13th floor. I have seen that.
But why, I wonder? I don't remember why. I like researching about things. Write down your lecture reference properly. Okay. So today we are going to deal totally about aircraft magnetism. A very simple thing to understand if you focus on every point. If you are distracted, if you miss out on a few points, one session is not enough for you to understand. So what you're going to do, if that happens with you, you have the weekend to yourself. You will be going through the session again to revise, giving you a strategy, taking the best out of it. You have one more question. If two aircrafts are flying very close to each other, will they affect each other's magnetic properties? Not really. That will not happen. Don't worry about it. That will not happen. But one time, what happened, so I had this watch, and I had it was relatively new, so I didn't know all the functions. So the manual was this thick, this small, this thick. So I was like, okay, I'll see. I just was playing around with the features, and it has good features. It's not digital, of course, but it has some features. So I was like, okay, I'll do some time, and I'll do it. But I used to just play around with it. I didn't go through the manual. I have a habit of going through manual of every new gadget that we have. It tells us how to do the best, make the best out of it. Be it your phones, be it your whatever systems you have. Every system will have a manual. You go through it and you can make most out of it. This is what aviation has taught me. So you will be taught to go through aircraft manuals when you go for flight training, especially when you go for type rating. We call that FCOM for A320 and other aircrafts. So that will become your guide. So what had happened was, um, just playing with the functions. One day, my time was mismatched by 3 to 4 hours in this, the hands, and I thought I've lost my money. I thought this is a defected watch, and I was just feeling bad about it, making a bad investment. And I didn't realize what happened. I'm like, why is this giving me wrong? I thought maybe I've just done some wrong function, and I was just not getting time to go through the manual. Then one day when I took a break in between class, I remember that day afternoon, I went on a walk and I sat down under the sky and I just went through the manual. I had kept it in my pocket. In the manual, I saw, and there was one issue in the manual that your time are mismatched. How to fix it? But the fixing part was not there in the manual. I'm like, how to find it? I went through the entire manual, and then I realized, oh, I should have seen the manual before. Then I thought, okay, this manual is not enough. Is this a duplicate product? I was not sure. Then I was again stressed. Oh, I made a bad choice, bad investment. And then I thought, okay, let's look up on the website of this company. So this company is very professional in making watches. So they have a collection of digital manuals respected to the models of watches. I was like, wow, this is good. Now I think I've made a right investment. And then I downloaded the soft copy of the manual, which I saw had that one part that was missing. And they said that your hands might be mismatched because of local magnetic field around your watch. And I was like, okay. And then I realized I used to keep it in the same stationery box where I keep my magnets and my other headphones and gadgets that have magnets. And I'm like, oh, so this is the reason. I saved myself a trip going to the showroom and fighting with people saying that, oh, you lied me or cheated me. This is something that I feel bad about. And I go and fight with people when I think they've cheated me. But I felt so nice that, okay, now I know. So this is just like how the compass can also be affected by local magnetic field, but only in the aircraft and the earth magnetic field. A compass needle will only be impacted by that. But sometimes your old CRT TVs, they used to get a pink or yellow shade on the screen, and we used to go to the repairman and tell them they used to say become demagnetized. We didn't know it then. Now we know that when you put a CD player or something which doesn't exist anymore, but yeah, then the influence of that magnetism used to impact the display of the CRT gun, twist and turn the electrons in a way that it was not giving us the RBG colors, red, blue, green combination, whatever it is. So it happens. Once you remove the magnetizing source, they work normally again. Here I had a permanent deficiency, which I was able to fix because they had a solution. But now I ensure that I don't keep the watch anywhere where there are magnets. So talking about what are the differences, what are the disturbances to my magnetic needle with respect to aircraft magnetism, I need to understand what are the two types of aircraft magnetism. As discussed, there are only two types of magnetism everywhere, depending upon the material: hard iron, soft iron. Now, who can tell me which component of the Earth's magnetism is responsible for the aircraft's soft iron magnetism? Is it the horizontal? Is it the vertical? Write your answers in the chat box. I don't understand why some students are always giving me opposite answers in magnetism. Students, if you don't work hard and fix it, you will lose your marks in exams. Have you not written the notes properly? Have you not revised the notes? Is this much time not enough for you to go through your notes? Which component induces vertical soft iron magnetism in the aircraft, horizontal or vertical? Sridhar, correct answer. Suchita, very good, correct answer. Muskan, correct answer. Out of 5, 3 answers are correct, 2 are wrong. What's happening? Students giving me horizontal as answer, what's wrong? If you don't master what we have done in the last class, learning in this class makes no sense. You will just keep increasing your backlog and then you'll blame yourself in the end. What is this point? What is this point? Read Zulu. Vertical force, vertical component has importance in magnetizing the vertical soft iron in an aircraft. See the keywords. Why are you giving me answer as horizontal? Would you care to explain so that I can help you? No, not interested to explain or discuss your doubts. Students telling me horizontal. So the key is vertical soft iron. But that is the only thing. There's no horizontal soft iron we are talking about. Everyone, read through your notes. See if you have any doubts. I'm giving you 5 minutes to do this task. And I'm also sharing the notes on the screen. Anybody wants me to scroll up and down, this will be the up, this will be down. You can just give me this reaction up, this down, I'll do it. Go through it. Don't rush. If you don't know this much, you'll miss out on what I'm going to teach ahead. And I don't want you to miss anything.
Good morning, sir. Sorry for joining in late.
Very good morning. It's okay. Pushkar, it's okay for you. At least you're joining. With my students, I'm always positive and optimist. But today I was reading a book, and in that book, they did mention that optimism is not always like I'm always possibly thinking everything will go my way. But we choose to believe that over a period of time, things will go our way, even though all along we will have some setbacks. So I was like very happy to see that, maybe I'm just like that, I was very happy to see that, okay, something like this generally exists. So if you focus, study hard, whatever you're doing right now in class, wherever, long-term benefits will be in your favor. It doesn't mean you will not get any hurdles along the way. So that is what people generally say, be positive, have a positive attitude, something that we get bored listening to. But this confidence that comes with being positive, that, yeah, everything's going to turn my way, is very important. But if you have a attitude like that, ultimate self-confidence, but you induce that confidence in a way where you see you are making silly mistakes and you don't care about correcting it, then it becomes complacency. Complacency is the enemy in aviation because it results into a lot of human error. So being positive and confident is good. Overconfident is not good. So what does it mean being confident here? Confident. It means that be confident that in the long run things will go your way. Doesn't mean in the journey you will not have setbacks or problems. You will have problems. You just have to sail through them with a minimum of losses. So it might happen, you might miss out on couple of sessions. You might have challenges in continuing with the sessions. Some of the other problems. Every student has different problems, but in the long run, you will get what you want. That is what it is.
Can you scroll down, please? Yeah.
Use all these techniques to get your best results in the exams. Simple. Is it too much to ask for? I don't think it's too much to ask for. Horizontal is good for compass and gives directivity. Thought would be, I don't understand the dot 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 here, but it's okay. Now we are going to also talk about a big contradiction in elements, but we'll come there, we'll come there. It's very important that we strategically approach this. Otherwise, aircraft magnetism being so simple can take you 10 days, 5 days, 2 days, depends. Just get done with this reading task. Any questions? So once again, very warm welcome, everyone. So not welcoming you all individually, but I hope you feel welcome. Here, the hard iron magnetism of an aircraft. Okay. When we talk about it, you write down this as a heading, hard iron magnetism, and write down the first point. I'm going to dictate it. Okay. And then I'll ask someone to give me a read back. Okay. The total force at the compass position produced by a permanent hard iron magnetism is resolved in three components. So what is hard iron magnetism? It's a total force experienced wherever the compass is, and it is produced by the hard iron magnetism. Now, hard iron magnetism, understand, is permanent magnetism of the aircraft. Okay. And it is resolved into three parts. Okay. These three parts, okay, will be fixed and will not change and not affect the aircraft heading. That is compass indication. This is a very important point. Generally, we will think that both the aircraft magnetisms are going to impact my compass heading, but it's not true. The manufacturers and designers of an aircraft are so smart that whatever magnetism the aircraft has permanent, they have resolved it in a way that it will not impact our headings. Simple. It will not impact our compass headings. So hard iron magnetism of an aircraft, not a big issue for us. If anybody ever tells you, how does it look like? So there is a diagram you could refer. Simple. And what are these three parts of the hard iron magnetism? Okay. We'll make a trio like this. Blue will show the north pole of the particular magnetism. And here a trio like this. Red will show it like this. And of course, the blue will always be on the top here. Why will blue be on the top, students? Because the south pole in the bottom will be closer to the north pole of the earth if the aircraft is flying. Now, this reference is very important to understand vertical soft iron magnetism of the aircraft or the soft iron magnetism of the aircraft. When I say soft iron magnetism of the aircraft, I talk about vertical soft iron only. There's no other horizontal soft iron magnetism impacting me in any way. Horizontal is good for me. Whatever magnetism I'll have, if it's horizontal, it's either going to be good only generally. But the soft iron magnetism or soft magnetism induced is because of the vertical force only. So it becomes vertical soft iron magnetism. This resolution of the aircraft's hard iron magnetism into three looks like this. So it will follow the three angles like this, three lines like this, then it will follow like this. So you see, they behave as if there are 3-bar magnets. Like this. The first bar magnet along the longitudinal axis of the aircraft, blue and red. Second is across, and third is also across. So these are the 3 parts of the aircraft's hard iron magnetism, not affecting the heading. So this is all that you learn about hard iron magnetism. That's it. Because it's not affecting the heading. What does it mean not affecting the heading? It's not affecting the compass indication. So of whatever we have of major concern here in aircraft magnetism is soft iron magnetism. Okay. What induces the soft iron magnetism in the aircraft? You will write soft iron magnetism is induced in aircraft because of soft iron magnetism is induced in aircraft because of surrounding magnetic fields. Now, let's say the other question that we had when 2 aircrafts are flying close. Now, of course, in civil aviation, 2 aircraft will not be allowed to be flown in a proximity more than required proximity. Proximity means closeness. But let's say there's a small aircraft and there is a big aircraft, and they both are close to each other on ground. That is possible. A few meters difference is as much as the aircrafts could be separated. Chances are the big aircraft's magnetic field could induce a little bit of disturbance in the small aircraft's magnetic components, possibly on a rare occasion. I would not say that will not be possible. But when aircrafts are flying, it will not happen. Okay. Generally, it is very least likely to happen, is what I would say. So, soft iron magnetism is induced in aircraft because of surrounding magnetic fields. Which is the main surrounding magnetic field? The main is the Earth's field. Okay. Most important factor is Earth itself. Now, what are the Earth's magnetic components? Earth's magnetic field components, horizontal and vertical. Okay. You just write down this point. For CPL, we consider soft iron magnetism caused by Z, that is vertical component of the Earth's magnetic field. Students, after discussing every point, I'm going to give you a couple of seconds to think about it and ask questions. Raise your hand, okay? So the pause is very important. I want you to master the understanding of it today itself, going step by step. Every point, if you have understood, that would be my assumption if you don't ask any question after a pause. Got it? Okay, you understand the strategy here? So we are only going to talk about Zulu. Okay. Now, what do you know about Zulu? The impact of Zulu will affect directivity. The impact of Zulu will increase as increasing latitudes. All that will stand true with respect to vertical soft iron magnetism only. Everything. So your understanding should be good. Nukul Chaitanya, are you following? Nice to see you all. Yesterday I could not see anyone. Today I see a couple of faces. Nice. Chaitanya, very happy to see you doing it. You were struggling to do it, but now you're doing it by yourself. Very happy to see that. Aditya, Gulshan, Prerit, I hope your attention power is not reduced if your videos are off. Because when we know sir is looking at us, we tend to study more seriously. When we know sir is not looking to us, we tend to not study seriously. Every student does that. This is one reason why I used to prefer sitting on a first bench always in my classroom. Because I knew if I sit on the last bench, we are going to have a lot of masti and fun and not studying. It will happen with every student. First bench, you cannot do it because people will see it, right? So you externally control your desires by doing that. So that helps, Aditya, same goes for you. I know Sridhar is doing it. I'm not worried about Sridhar. Others also I'm not worried about. Pushkar a little bit, but it's okay.
Yes, sir.
Yes. I'm not sure if you're learning or you're doing multiple things along with lectures. So yeah.
No, learning.
No. What does that mean? I don't know. So yeah. Everybody knows what is vertical component of the Earth's magnetism. Can you tell me whether it increases or decreases with latitude? Who will give me this answer? Sridhar. Vertical component of the Earth's magnetic field increases with latitude or decreases with latitude?
Sir, it increases with latitude.
Very good. Next question. The angle of dip is directly proportional to vertical component. True or false? I will tell Prerit. You give me the answer. Prerit, इतना time मत लो यार.
Sir, can you repeat the question, please?
Wait. Aditya, repeat the question and give me the answer. Prerit, please सुनना question को अच्छे से.
Yes, sir.
Sir, I forgot the question.
ठीक है. चैतन्य, आपको याद है question?
Sir, the question was, it is true or false that the magnetic dip increases with the latitude? Guess.
Muskan, please, do you remember the question? Yes or no? Try to say it and give me the answer also.
Yes, sir. The question was magnetic dip is directly proportional to vertical force. Is it true or not?
And the answer is, Muskan?
True, sir.
True, very good. अब समझ आया बच्चे लोग किसको मैं बोल रहा हूँ फोकस बढ़ाने को और किसको नहीं बढ़ाने को. आपको लग रहा होगा आई एम बायस्ड और समथिंग, राइट? डू यू अंडरस्टैंड? अगर आपको बार बार कोई चीज बोला जा रहा है ना, वो आपके अच्छे के लिए बोला जा रहा है स्टूडेंट्स, है ना? अच्छा करने यहाँ पे आया ना हम लोग, पढ़ने, नॉलेज लेने, पास करने, अच्छे पायलट्स बनने. प्लीज भूलना मत इस चीज को दोबारा. प्लीज फोकस रखो. हर चीज 3 बार पढ़ाने जाऊंगा कि क्या फायदा होने वाला है तुम्हारा और मेरा? सोचो. उसकी आदत क्यों डाल रहे हो आप लोग? मैं कर सकता हूँ बट उससे तुम बिगड़ नहीं जाओगे. ज्यादा पैम्परिंग अच्छी नहीं है ना. So angle of dip is caused due to the vertical field force of the Earth's magnetic field. It's directly proportional to the magnetic dip. Magnetic dip is directly proportional to that. The word proportional is very important. And one more question I have. You will raise your hands, whoever knows the answer, okay? Angle of dip is inversely proportional to the dash component of the Earth. Option A, vertical. Option B, horizontal. Option C, total. Karishma, tell me the answer.
Sir, horizontal component.
Very simple, horizontal component. Very good. Any doubts, students? Very good. Next question. Angle of dip or magnetic dip angle is the angle measured between dash. Option A, horizontal and vertical component. Option B, horizontal and total component. Option C, vertical and total component. Jyotsna, give me the answer.
So it's horizontal and total component.
Very good. Correct answer. Nukul, क्या चल रहा है नुकुल? सब उल्टा पुल्टा हो रहा है. फुर्सत निकालो और अच्छे से रिवाइज करो, सब सही हो जाएगा. नुकुल, डू यू वांट टू डिस्कस क्यों उल्टा पुल्टा हो रहा है?
पता नहीं सर.
क्या प्रेशर क्या आ रहा है? What's the pressure?
So I think I have to revise once again.
नहीं नहीं, यहाँ देखो ना, मैं बता रहा हूँ ना, रिवाइज क्यों. Remember, H and Z are always perpendicular to each other. Angle of dip is when the horizontal or the magnetic meridian, this is horizontal, and when the total force, this angle. Because yesterday we had spoken about it, the total force is which along with the magnetic needle will dip. So if the total force is, if T is equal to Z, then it will be like this only completely. It means this is my horizontal, so it will be 90 degrees. When I'm making dotted line, it means it's just showing the horizontal here. And when I say my total force is equal to H, which is on the magnetic equator, then if this is the horizontal, then this is my horizontal here, H. So I see the angle is 0. So magnetic dip angle on the magnetic equator is 0. On the poles is 90 degrees. In between, it will be increasing as we go towards the poles. The key is to memorize this over here. Okay. Nukul, easy, right? ये समझ आ गया आपको?
Yes sir.
तो फिर क्या कंफ्यूजन है बताओ? क्या है एंगल ऑफ डिप यहाँ पे बताओ, किसके बीच में आ रहा है? डायग्राम याद कर लो बस, कभी नहीं
The
भूलोगे.
total force.
H and total force, yeah. H and total force. It is caused because of Zulu, but it's the angle measured between the horizontal and total force. Your horizontal, you will only get on the equator, students. There the angle is 0. After that, the dip will always be there. Simple. Any doubts? Don't feel bad. Take your time. Time लगता है इन सब चीजों को. To me also, it took some good time. Every student takes some time. Don't worry. Don't be so harsh on yourself, students. Just try to be right. आंसर देने से पहले 2 बार सोचो, तो आपको करेक्ट आंसर मिल जाएगा. लिख लिया करो ऑप्शंस, ऐसे याद नहीं रहते तो. So we call for soft iron, we are only taking the soft iron magnetism induced in the aircraft by the vertical component of the Earth's magnetic field. Got it, students? Okay. Write down the next point. The vertical component of the Earth's magnetic field. Students, other than Nukul, at least he's asking doubts and giving me answers. 80% of the class is not even giving answers. So we will never know you are right or wrong. At least Nukul knows his area of improvement and he will do it nicely. What about y'all? Think about it. So Nukul is in the right direction when it comes to studies. He's trying and he's trying. Right or wrong doesn't matter in a class. You can be 10 times wrong in a class. It's okay. It's how studies are. But have you ever noticed he's always answering? There are only a handful of students who will always answer. Some of them are wrong, but still they answer. I like that. I really appreciate it. So you don't give up, I don't give up. And you don't get scared when I get a little stern or serious. That's it. That's the worst that could happen, right? So that's a good thing, Nukul. Don't worry. आज एग्जाम नहीं है, कल एग्जाम नहीं है, ऐसे सोचना है सर. एग्जाम के पहले हो जाएगा, मेरे को भरोसा है. ऐसे. So we're talking about optimism and hurdles. These are tiny hurdles. It doesn't mean you'll not get the results or the knowledge. समझ गए? We all have our own weak point in terms of fundamentals where one point we have learned wrongly or skipped, because of which all errors happen. Our job is to go back to that point and figure that out as a final element of the study phase. समझ आया सबको? So the Z component, write down, has an increasing effect Z component has increasing effect with latitude. Now I'm going to give you a keyword statement, very helpful to understand questions, but it doesn't change anything that we already know and doesn't give us anything that we don't know right now. Z has increasing effect with latitude as the compass magnets try to follow the Earth's flux lines. As the compass magnets try to follow the Earth's flux lines. Now, students, there has been an experiment done at a pre-primary level where we take dust, iron, or magnet. I would say dust of iron is much better here because dust of magnet will have a lot of small bar magnets. And what happens if I take a strong bar magnet? Okay, a strong bar magnet. It's not free to freely suspended. Okay, it's just there on the ground. So let's say this is the north pole and the south pole of this bar magnet. So the fields of force, although invisible, we can just draw it for a reference, going from north to south. Okay, like this. I'll just show you the arrow also. Remember this, okay? A very simple question asked. The same is true for the Earth also, from South Pole to North Pole, magnetic South to magnetic North. Okay. Now, if I take dust of iron or magnet, okay, dust, like this, a lot of dust. And if I put the dust in the influence of this magnetic field of this magnet, then the dust aligns itself automatically in straight lines, like this. So the dust will align itself like this. Why is there a delay? This experiment proves that all magnets, when they are sensitive enough to be influenced by any particular magnetic field, then they will try to align themselves with the lines of flux of a magnetic field. That is what we call as a magnetic meridian when talking about a compass needle aligning itself with the magnetic north and south. It will be pointing towards the north, but it will be aligned across a magnetic meridian. A magnetic meridian can be said with respect to Earth as like this. If this is North Pole and this is South Pole, then the magnetic meridian on the surface of the Earth could be said to be existing like this in both hemispheres. There could be something like prime meridian also, and like this. With respect to the surface of the Earth, like this, to understand. So wherever there will be a compass, like this, the needle will try to align itself along with the magnetic meridian, pointing towards the North Pole with respect to the laws of attraction and repulsion. So these are valid points and key points that we need to understand so that we are able to nicely identify questions and the problems and give solutions. Getting it, students? This is in-depth learning. That's it. It's the learning of basics with all elements explained. So this statement now makes much more sense, right? Anybody who doesn't understand this statement, please raise your hand. Earth's flux lines. I'll write flux again so that tomorrow or day after tomorrow, if I ask you questions, you're like, oh, sir, I forgot. That should not happen. Flux lines. So all the magnetic field forces can be said to be existing in individual lines. That's where we get magnetic meridian from. Flux lines as seen when iron dust is aligned. Dust. Write down the next point in vertical soft iron magnetism only. Now you can just talk about vertical soft iron in the entire page only. Hard iron is done. So although we are making a table now, you can just take the entire page and continue writing for your vertical soft iron magnetism. Okay, I'll also do the same for you. So now we are describing vertical soft iron magnetism only under soft iron magnetism. Right on the next point. VSI magnetism varies with latitude. It means the induction of the VSI magnetic field will vary from latitude to latitude for any aircraft. It will not be the same. Okay. VSI varies with the latitude. Aircraft's VSI, aircraft soft iron magnetism, vertical soft iron magnetism will also varies with the latitude. Any doubts? Next point. As Z is 0 at the equator and H is greatest at the equator, as Zulu is 0 at equator and H is max or greatest, no VSI, that is vertical soft iron magnetism, no VSI magnetism is induced over the equator. Very important point. You can be asked this question anywhere, anytime. Interviews, airline entrance exams, or maybe navigation exams, ATPL exams. That on the equator, there is no VSI. Why? Your compass is not influenced by the aircraft's vertical soft iron magnetism on the equator. Why? You will say because it doesn't exist only. Why? Because H is max and Z is 0. And Z is the factor inducing VSI. If Z is 0, what will induce VSI? And if there is no VSI magnetism, then what will impact my aircraft's compass heading? Nothing. So that is the explanation. They can make you ask a question wherein you might not relate it with the Earth's magnetic field only. You'll be like, oh, I didn't learn this in the compass, so I missed learning it. No. Break it down to this explanation. Very important explanation here. Such things can help you score better in your future airline interview group discussion sessions also. Now, multiple rounds for airline interviews. This knowledge is what they will ask you primarily. Very good. Any questions? Now see the two types of magnetic compasses. I just had it. Screenshots. 1 second, okay? Okay. Okay, I'm not finding it. Give me a second, okay? I'll show you the pictures in some time. I'll show you how the vertical soft iron can be induced, okay? Be very careful looking at this diagram, okay? When I say types of VSI, understand carefully how it would look like in an aircraft. I'm showing you 3 different situations when looking at the aircraft from the side view. Then I'm going to show you one situation to show you aircraft from the top view. Okay. So the compass that we are talking about, okay, we can say that direct reading compass is a compass that has a bowl in it, a bowl type compass. Bowl or a bowl, a small bowl wherein, you drink soup or whatever you like to have generally. A compass that we use also has a bowl. In the bowl, there is a vertical card, and that vertical card has magnets. So the bowl will look like this. This is just a bowl. In the bowl, we have a vertical card. The vertical card has magnet needles. They move the vertical card. And as a pilot, if you are looking at it, then there will be a small window. This will be in a horizontal housing. In the window, the glass separation would be there, and there will be one white line known as lubber line. And that lubber line will show you the heading directly, anywhere from 0 to 360. Okay. So although this is this is a Tibetan bowl, this is not the compass bowl. Okay, it's too heavy to be induced in an aircraft compass. It cannot be used. But yeah. So let's say that ball somewhere is here. Okay, here in the cockpit of these aircraft, direct reading compass. Okay. I'll just color it in yellow. So this is your magnetic compass, okay? Location. Now, where would the vertical soft iron be induced and how would that look like? There are many possibilities. Okay. So the first possibility will say that the VSI is forward of your magnetic compass. Okay, FWD. Second, we'll see VSI is aft. Aft of what? Aft of your compass itself, whatever compass you're using. AFT aft, FWD forward. And the third instance would be fore and aft. VSI fore means forward and aft. How would it look like? So I'll show you the vertical component Z will keep acting, let's say wherever the CG is or whatever, at the same place. This is where the vertical component is acting. Zulu, Zulu, Zulu. But with respect to any aircraft, okay, with respect to any aircraft, the soft iron magnetism induced could be different. Okay. So when I say forward, it would look like this. North Pole, South Pole. South Pole will be always at the bottom because that will be attracted by the Earth's North Pole in a closer way. This is vertical soft iron magnetism. Be very careful. I think this is one point where people are associating blue with blue somewhere. I could find that flaw written somewhere in the book. It's not a flaw to an observant student, but somebody who is not well versed with basics, but just reading one point or thought one point with respect to VSI. This is where blue and blue are together. This is the only place where blue and blue are together in your aviation text. Why, I will show you. But remember, this is the vertical soft iron magnetism now. So this bar magnet induced here means the magnetism or the magnetic field would be like this. So it will be inducing some distraction for my compass, which was supposed to be only influenced by the Earth's magnetic field surrounding it. But in its immediate vicinity, we are having this vertical induced magnetism, soft iron. So it's temporary. It will change with respect to the changes in the latitude, changes in the component of the vertical component of the Earth's magnetic field. Getting it, students? Why is it temporary now? Why is it called soft iron? Because it's temporary. The moment I take my aircraft over magnetic equator, it will reduce completely. The moment I take it towards the pole, it will be maxed. The moment I come to mid latitudes, it will be in between the 0 and max. So it's temporary. That's why it's called vertical soft iron magnetism. So you understand everything about vertical component. Understanding about soft iron magnetism of the Earth is also of the aircraft is also very easy. Are we following, everyone? One student is gone from the session. So whenever that happens, I'm like, okay, one student has given up as a joke, you know. It's like a marathon. Only a few will survive. Okay. So what about aft? What if the vertical soft iron magnetism is aft? Then, of course, it will be behind. Somewhere behind like this. Again, the north will be up, south will be down. Okay. This can also influence my compass. Definitely, my compass needle is very sensitive. A little bit of influence will always be there. And when I say fore and aft, chances are the soft iron magnetism would be such that it will occur both fore and aft at the same time. Now, this is vertical soft iron. This, I say, is acting anywhere on the longitudinal axis of the aircraft here. Longitudinal axis of the aircraft is the imaginary line passing from the nose of the aircraft to the tail of the aircraft. A very important axis, one of the three important axes of the aircraft. Sometimes vertical soft iron magnetism could also occur not along the longitudinal axis, but along the lateral axis also. Which is the lateral axis? An axis passing from the wingtip to wingtip. So my soft iron magnetism could be induced somewhere here also, like this. It's possible. So this thing, if I have to look from the side view for this aircraft, because it's on the right side, the same thing if I make for you like this and show you this wing, then I see that this magnetism over somewhere on the wing looks like this. Like this, on the wing, not on the longitudinal axis. So this will also impact side view. Same. So let's try to visualize and imagine. It might not be easy directly, but it's not difficult. All you need is practice and some revision. These are very difficult terms to understand on your own. I agree with that. But now that I'm helping you do it, you should find it comparatively easy. And couple of revisions, you should be like, sir, ho gaya mera. I'm done. Very good. Okay. Just finish your diagram saying this is the compass bowl or the compass. Compass bowl means housing of the compass here, nothing else. And I like, at least from my end, I like when I'm, not teaching in a rush. I like this comfortability that I'm feeling and that you are having. But if you're not finding yourself comfortable, do let me know. So we can say that the vertical soft ion, write down, note, the VSI magnetism induced is such that it seems like virtual bar magnets, or it seems like imaginary magnets. It seems like virtual bar magnets or imaginary magnets affect our compass. So the diagram that we have made is for our understanding to see how it is induced. Not many people will know this, students. But we have to use the words imaginary magnets. But the strength of the force is true. Strength of the force is true, real. Okay? So do not be confused if you get the word imaginary magnets now in the questions. Write down the next note. Blue pole is referred to as the North Pole. Okay. In bracket, you'll write of these imaginary magnets. Close the bracket. Blue pole is the North Pole. In bracket, you'll write of the imaginary magnets. Write down the next point. Very important point. Effect of VSI magnetism with different headings. On compass. Very important point. Before break, we will discuss these points. Okay. So first you will write heading 0, 0, 0 degrees. Compass. So we're talking about compass heading right now. If my compass heading is as true, is correct with respect to my magnetic heading, good for me. But if my compass heading and my magnetic heading are different, it means there is a deviation in the indication. This deviation is the problem in my directivity. Students who have done directions, lecture 1, lecture 2 of these series of lectures, you know what I'm talking about. Students who don't know, I'm introducing it to you now. What the compass shows and what's the real magnetic heading, and what the compass shows, if there is a difference between the real and the compass, then the difference is called as deviation. Compass heading being on the right of magnetic will become easterly deviation. Right is east. Compass heading on the left of my magnetic heading will be westerly deviation. These two terms will always come to you hand in hand. This is where the ultimate contradiction happens with respect to plus sign and minus sign. Easterly deviation is referred to as minus sign. Write down, everyone. When you're trying to solve the value of CDMVT deviation variation, if you have to show that in a CX3, the computer that we use in the exams, the calculator, the computer, easterly deviation will be negative symbol. But when you compare it with respect to the practical application of finding magnetic heading from compass, when deviation is given to you, you use the opposite symbols. Those symbols are not symbols, but uh, it's a sign of execution whether you should subtract that value or add that value to the compass heading to get magnetic heading. This is very simple to understand, and yet if you don't focus, you'll only get it half of the times right. Whoever has got it, good. Whoever's not got it, I'll be doing it again now only. Let's come ahead with the differences in the headings first. Heading 000, you write down, okay? Now what will happen, heading 000, what does it look like? This is my aircraft, okay? And we are going to assume that I have had a forward vertical soft iron magnetism. This is how it will look like now. Okay, from the top view, does everybody agree? This is the forward VSI North Pole. Simple. Specified for you. This little dot. Now let's say this is my compass. And now my aircraft heading. What is my aircraft heading, students? My aircraft heading is the direction in which the nose of the aircraft points, or the direction in which the longitudinal axis points. Everybody write down this definition of heading. Heading is the direction in which the nose of the aircraft points, or the direction in which the longitudinal axis of the aircraft points. That is heading. I say again, heading is the direction in which the nose of the aircraft points, or the direction in which the longitudinal axis of the aircraft points. Okay. Next point you write, heading is also measured from a reference north. If measuring magnetic heading, the angular measurement will be clockwise from magnetic north. Heading is also measured with a reference north. If we want to calculate magnetic heading, it is measured clockwise from magnetic north. And if we are calculating compass heading, then that is measured clockwise with reference magnetic north. Correction, with reference compass north. So if we are measuring compass heading, then it is measured clockwise from reference compass north, not magnetic north, compass north. So this is my longitudinal axis. Heading 00 means I'm heading north, and a half triangle like this shows me my magnetic north. It can be on the left side or the right side, doesn't matter. This is the symbol. Here, if I look carefully, my compass needle is also pointing towards north. The arrow on this small diagram under yellow, the arrowhead shows you the north-seeking pole. I'll make it red like this, so you know this is the north-seeking pole of the compass needle. Now, students, what is happening here? If you carefully look, the first effect that the compass needle has to point is by the vertical soft iron north pole. But the good thing is, because my aircraft is going towards north only, they both are in alignment. So I don't see any deviation whatsoever. So write down what is deviation, everyone. Deviation is the angular difference between the magnetic north and the compass north. It's always the north and north, not the directions. I say again, deviation is the angular difference between magnetic north and compass north. Next point you will write. When the compass north, about deviation only, okay? When the compass north is on the right of magnetic north, when the compass north is on the right of magnetic north, that is to the east, then the deviation is called easterly deviation. When the compass north is to the right of the magnetic north, that is to the east, then it is called easterly deviation. In CX3 computers, it is denoted by negative symbol. Very important point. In CX3 computers, it is denoted by negative symbol. Okay. Next point you'll write about deviation. When the compass north is on the left of magnetic north, that is on the west of magnetic north. When the compass north is on the left of magnetic north, that is west of magnetic north, it is termed as westerly deviation. It is termed as westerly deviation. Next point you will write. In CX3 computers, it is denoted by plus symbol. Focus on what I'm saying, okay, students? I told you there is a contradiction. You're not listening to my point. I'm talking about the functions to be used in CX3 when solving these sums. It is very important you remember this. The other plus minus that is contradictory is not a determinant of whether the deviation is east or west. It is a determinant of whether you should subtract or add the value of deviation to get variation. We are talking about the definition of easterly and westerly deviation right now. Do you understand what am I saying? Students discussing this doubt with me on chat box. Are you understanding what am I saying? It's like if you have to give me a code, my name, and if I'm easterly deviation, then my name would be minus. Let's say I have my deviation value as 5, easterly deviation. Then if I have to write it, then I'll write minus 5. Minus 5 deviation means easterly deviation. Remember this. Very important fact. Study it carefully, students. In your textbooks, you will come across deviation west having in a sequence where they are comparing compass heading, deviation, and magnetic heading. You will see west is associated with a minus symbol. Understand they are not describing the deviation there. They are just saying that to get the magnetic heading, if deviation is west, you subtract it to get magnetic heading. So they are giving you an instruction there. This is why students are not able to clear exams because the textbooks are so confusing. Somebody should take effort and fix this issue or introduce this line wherever these points are introduced in the textbook for you to understand the contradiction. Believe me and follow this for your own sake. It's not my invention. It's my research, nothing else. Do you understand, students? Do you understand the difference? Whenever you come across this difference in your calculations, you will let me know. Did we write the description of deviation west for a CX3 will have a positive sign? Write this also. The description of deviation west, especially to be used when using CX3 for calculations, west deviation should have a plus symbol. Students, don't have this sad face, okay? You are learning it. You think flying is easy? It is very difficult. You make it easy after approximately 5 to 7, 8 years of experience. Even then, pilots will say it's not that easy. It is never easy. What they show you on face is a poker face, okay? Whatever you see online, you think everything will be that easy. The moment you turn on the aircraft, the faces change, okay? But they will never show that to you. It's a sign of weakness and they're not allowed to show it, neither feel it. If you're thinking, oh, why am I studying so much? I just want to fly. Even flying will not be that easy. You'll realize, and I don't want to say, but you will realize when you're facing bad weather and you have to land the aircraft by yourself. Then you will know. A fraction of a second, couple of mistakes, and everything would go south for you. It's very difficult. You need to practice, 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 practice till the time you get a hang of it. So many pilots with so many years of experience, they have to initiate go around and missed approach on a regular basis. Why? Because it's difficult. Because the situations around make it so difficult. So please don't take it for granted, okay? And don't think you're doing something that you're not supposed to do right now. Again, write down important note. While deriving magnetic heading, when you see a compass heading and you know the value of deviation, while deriving magnetic heading, when you see a compass heading and value of deviation is given to you, then if the deviation is westerly, you will subtract, in bracket you will write minus, bracket close, the value of deviation from the compass to get magnetic heading. In order to determine magnetic heading, when you see a compass heading and you are given a value of deviation, for a westerly deviation, you will subtract, in bracket you'll write minus, bracket close, you'll subtract the value of deviation from the compass heading to get magnetic heading. This is the situation where a westerly deviation can carry negative symbol in certain textbooks to derive magnetic heading. Nakul is like, "Sahi kar rahe ho, sir, aap best hai."
No, sir, I mean to say, please slower. I have
Oh,
missed.
मेरे को लगा तारीफ कर रहे हो. आप तो बोल रहे हो, अरे सर आप तो बहुत फास्ट बोल रहे हो. Somebody please give a readback of the last statement.
While deriving magnetic heading, when you see a compass heading and value of deviation is given, then that deviation is westerly, you will subtract the value of deviation from the compass heading to get magnetic heading.
And after this, thank you, Jyotsna. After this, the last statement that, what was it? This is the place where you will see a negative symbol associated with a westerly deviation. in major textbooks? This is to clarify this doubt, students. Sushita, are you getting it or not? Rohita, Muskan? I think Muskan is not there. Sridhar, are you getting it? Pushkar, are you getting it? Gulshan?
Yes, sir.
Karishma, good for you, right?
Yes,
Any
sir.
questions? Aditya?
Yes,
Prerit?
sir. Yes, sir.
Everybody knows deviation east, compass least, deviation west, compass best. That also tells you whether to subtract or add. Okay? The same will stand true to derive magnetic heading when compass heading is given to you and deviation is east. In that case, you add the value of deviation to the compass heading to get magnetic heading. This is the only place where you will see deviation east having a positive symbol. It means add it to the deviation to get magnetic heading. That's why the plus symbol, to make it much more easy for the pilot. But with respect to the theoretical concepts, easterly deviation is denoted by negative symbol. That symbolism is different. Be very careful or you will get wrong answers, and the exam questions are like that, that the wrong answers carry. Wrong answers that you come are also given in the options. So if your option matches, but if you've got a wrong answer, but wrong answer matches one wrong option, you will write that option as correct option because you think, oh, my answer is matching, it means it will be correct. But they are very smart when they are setting papers. They will give you one right option and two wrong options, but those wrong options would be the major wrong mistakes that people do all the time. This is why we say we have attempted 80 to 90 marks, but still we have got 60, 65. Because we made a silly mistake, but our answer matched, so we wrote the right answer, or matching answer, not the right answer. That's why I say cross-verify it twice. So I'll just show you easterly, westerly deviation. Okay. What is the definition of easterly deviation? East is right. It means the compass north is on the right of magnetic north. So I can say this is my magnetic north. And my compass north can be denoted like this, C. And westerly deviation, this is my magnetic north. Compass north is on the left. Easterly deviation, I'll say minus symbol. Westerly deviation, I'll say plus symbol. This is the naming, not the addition or subtraction to get it. Now, if I give you example, okay, and if I tell you, this is my aircraft actual heading, okay. What is the heading of the aircraft? The direction in which the longitudinal axis points. So this is the heading. If I tell you that example, deviation is minus 10. It means this is easterly deviation over here. Okay. And here I'll tell you example, deviation is plus 10. It means this is westerly deviation. Remember, we're not talking about adding or subtracting. We're talking about the nomenclature, the name, the identifiers. Okay, very important disturbance this is. And let's say even this aircraft is also having a same magnetic heading. So what is the magnetic heading of the aircraft right now, students? This is what we are required to determine. But with respect to this example, we will first see what the deviation is. Deviation I'll write in red. The angular difference from magnetic north and compass north. This is deviation. So I'll say this is minus 10 deviation, easterly deviation. Okay. This minus is with reference to when we compare it with the magnetic north now. And that is what your CX3 undertakes. The programming is such that it will always measure it with respect to the magnetic north only. Magnetic direction will be measured and variation will be measured with respect to true north. And compass will be measured with respect to magnetic north. So magnetic north is stationary over here, the reference. So you cannot play with the computer because the program is in just one way. But your textbooks, wherever they show you opposite directions, they compare it with the compass north and magnetic north so that it becomes opposite. Somebody should award me for this, you know. I feel so proud about having this clarity for my students. Really, it is not easy. Not many people know this. And here, I will say the deviation in this case, see the arrow, magnetic north to the compass north. Again, in this case, it is westerly deviation. Now, why is this minus and plus justified? Now my compass north. Okay, my compass north is this. If I want my compass heading, then my compass heading will be measured from reference compass north to the aircraft longitudinal axis. So this becomes my compass heading. So my heading compass, let's say, for example, my compass shows me, so this is given, this is something that I can see from the compass, is 080. Okay, compass. What is my magnetic heading over here? My magnetic heading is from the magnetic compass to the aircraft longitudinal axis. So I see my heading magnetic is 0980 magnetic. So the difference between magnetic and compass is 10 degrees. That is my deviation over here. With respect to the westerly deviation, my compass heading is measured from compass north to the aircraft longitudinal axis. It looks like it is 100 compass. And if I have to compare my magnetic heading, then I see it is the same. Magnetic heading 90 degrees, 0980 magnetic. So what makes it easier for the students to memorize or directly calculate are couple of rhyme schemes that people have devised. That the rhyme schemes are like this. Deviation east, compass least. It means if deviation is east, and when you're comparing compass heading and magnetic heading, then the compass heading will be lesser than the magnetic heading by the value of deviation. For westerly heading, we get the rhyme scheme as deviation west, compass best. It means if the compass north is on the left of magnetic north, the compass heading will be more than the magnetic heading by a value of the deviation itself. Then you compare. My deviation is east. Yes. Is my compass least? Yes. 080 is lesser than 0980 stands true. So here it means 080 compass is least or smaller than 0980 magnetic. And here I see 100 compass is greater than 0900 magnetic. Done. Any questions? I know one question. Sir, break कब दोगे? Apart from that, any other question? All right. Let's take a short break. And let's come back at 1300, everyone. Okay. Be mentally prepared if the class stretches for another 15 minutes or so. Be prepared. And students, about the methodology live class, whoever will be attending, I'll be not doing a live session for you, but I'll be instead sending you the textbook notes for Meta to go through once again and park all your doubts. So you can also revise a bit of navigation in that amount of time if you want. Okay. Just giving you a heads up so you can keep your afternoons open. So short break. When we come from the break, we will be discussing the various components of the soft iron magnetism with respect to remote reading compass and direct reading compass. Not much, but new points, but at a faster pace. Chalo. I'll see you students in some time from now. Sorry. Sorry. Yeah. Students, welcome back. Something strange with time, right? When we are in a class or working, time goes slow. But when we are on a break or a holiday, time goes fast. Very strange. If you know why this happens, do share with me also. So I hope Aditya and Suchita, of course, you're back. Welcome back. I can see. I hope Nukul, yes, Nukul is also back. I hope Prita, Sridhar, Gulshan, Pushkar, Rohita, Krishma, and Jyotsna are also back. Muskan, for
Yes.
some reason, is not there. I'm not sure. Where is she? I think everybody else is there. Divanshu is not joining in today. I don't know where he is. And I think Likith is out. So he's not there. And Chaitanya has just joined. Okay. Any doubts? Any doubts? Okay, good. Let's quickly write down the next part of notes and make it much more easier for us to understand going ahead. Now, students, I will complete the effect of our vertical soft iron magnetism, the diagram that I was making, with respect to different headings. And after that, we'll keep it short. So let's bring our focus back to this particular diagram and write down the same on our different headings. It was very important for us to know what deviation is before we could go ahead. If you're thinking, sir, why did we stop? Okay. So heading north, my compass needle is definitely over here being affected by the first imaginary magnet induced vertical soft iron magnetism. But just because they are in line with the magnetic north, I don't see any impact of the vertical soft iron magnetism on my compass heading when I'm following a magnetic heading of north. These are simple questions in the exams. Okay, so you should know this, that when I'm following magnetic north heading, if there is a forward vertical soft iron magnetism induced, forward means ahead of the compass, then there will be no deviation for me, subjective like that. Okay, write down the next point. As the aircraft turns right, so this is the one where we'll talk about heading 045. Okay, let's say we are changing our heading and going towards the compass heading 045. Okay, what would happen? My magnetic north is still in the same position, it's fixed. Okay, my aircraft is changing its heading, so this is the longitudinal axis. Then I'll make my aircraft wing like this. So when my aircraft is changing its heading, okay, now what will happen? The vertical soft iron magnetism induced ahead somewhere here, it will go slightly on the right also because of the CG effect, but you can assume it to be somewhere on the longitudinal axis. It's fine. Now, because of this, the impact on my magnetic compass is such that my magnetic compass needle, the north seeking needle, it is under the influence of two north poles. One would be the vertical soft iron magnetic north pole, and the other would be the Earth's magnetic north pole. So the total force with respect to the directivity here would be such that my compass needle would show me somewhere here, like this. The vertical soft iron magnetism is not that strong that it will deflect it completely, but it will influence it a little bit. And this becomes my compass heading like this. So now I get a deviation in this case, where I see the deviation is easterly to the right of magnetic north. So on a northerly heading, no deviation for me. As I start turning to the right, deviation will start. Okay. Now let's say we are having a heading of 90 degrees. Compass heading, let's say 90 degrees, or aircraft heading. Both will be the same. We are depending on the compass to give us aircraft heading only. But because of this vertical soft iron magnetism on latitudes other than equator, I'm getting a variation. So you say compass or you say whatever magnetic, it will be the same only for us here with respect to this. It's just that the compass is not showing us what it is supposed to show us. Because of the vertical soft iron magnetism, because of the north pole of this imaginary magnet, if it is ahead of the magnetic compass. See, I'm breaking it down again and again. Turning further right, okay? Turning further right, when your magnetic heading is 90, so magnetic north will remain straight. Let's say that I'm going with a longitudinal axis here. So my aircraft is like this, heading 90. Okay. And let's say my vertical, this is here, aft, correction forward. What will happen to my compass? Here, my compass will be stretched between the right magnetic north, the virtual one, and the aircraft, the Earth's magnetic one. And it will show me a further more like this, a little increase than the earlier one, like this, in between the two. So you see, as you go right on 90 degrees, the deviation will become maximum. Okay. So the aircraft turns right towards 045, the deviation will increase. And by the time I reach 090, the deviation is going to be maximum. And as you increase, coming from here, when you increase your heading further back from 90 to 135, 145, 155, your deviation value will start decreasing again. Okay. So write down this point. Continuing right from heading 090, the deviation value will become less as we approach heading 180. Here also, because the alignment will be the same, I'll show you the next headings. Let's say 135, compass or magnetic, the same for us. Quickly. So 135 would look like this. Angular measurement of 135. This is my aircraft. So 135 like this. So I'll make my aircraft. And now what is happening? The value will decrease compared to the maximum value on 090. Remember, the compass now will also start pointing again towards the north. Remember, it will not now follow the imaginary magnet north anymore. After east, it will start going towards my Earth's magnetic north now, because that is the strongest field now. And when I'm talking about 180 heading, then if this is magnetic north, 180 would be this is the north. So my compass here will show magnetic north directly like this straight. So 180 and 000, both headings will don't not have much of deviation because of VSI, because they are aligning with the magnetic meridian. Remember, the north-seeking pole will always point towards the magnetic north. Only between 0 to 90, it increases. From 90 to 180, it will further decrease again. So this is a key point for you to understand carefully, students. Okay. And remember, if you are thinking, sir, the arrowhead should point towards the blue dot on the forward magnetic VSI. No, no, no. Why? It will point towards the stronger north pole, which is the earth only always. It's just that certain headings, the value increases, and certain headings, the value decreases. What are these headings when the value increases? Apart from north and south, the value will increase till north, then decrease till south, like that again. So it's a sine curve. We call it a positive sine curve, just like an AC current. Increases, decreases, like this. Write down the next point. At 180 heading, the magnetic meridians act along the same line and the compass needle is pointing towards the stronger magnetic north. That is the Earth's magnetic north pole. As they are on the same line, same meridian, there is no deviation. Next point you will write on headings from 180, 180 to 360. On headings from 180 to 360, we will experience westerly deviation as the compass north will point towards the west of magnetic north, and will give maximum westerly deviation on 270 degrees. So it's opposite. So eastern hemisphere, you get easterly deviation. Western hemisphere, you get westerly deviation. So we can say 0 to 180. If your heading is anywhere from 0 to 180, you're only going to get easterly deviation, which will increase from 0 to 90 degrees and decrease from 90 to 180 degrees. And now when we are comparing the Western hemisphere, that is 180 to 360, if any aircraft is on a heading of 180 to 360, anywhere between, they will experience westerly deviation. The compass north will be west. So whatever compass north I made right on the right compared to magnet north in these diagrams, it will change. It will go there. So these are, if you can manage to, revise and study them very carefully or understand right now, then you will get 10 on 10 on these points. If there is a test anywhere in magnetism, deviation, variation, no room for error. So write down from heading 180 to 360, aircraft would experience westerly deviation as the compass north will be west of the magnetic north, and the maximum deviation would occur at 270. Just like 90 degrees at max, here starting from 180 to 270, maximum deviation would be at 270. And as you go ahead from 270 to 360, it will further fall back. As you reach 360, zero deviation again. Getting it, students? Easy? So I'll just show you the sine curve and explain it to you. If you don't understand, it's fine. If you understand, it's fine. Okay? east, west. Okay. I'll say this is 0, 0, 0, this point. I'll say this is 0, 4, 5. I'll say this is 0, 9, or 0, 1, 3, 5. Let's see if you understand this. Not forcing you all, but this can be understood when I'm explaining this. And then after 180, you will have what? 2 to 5 quadrantal points, then 270 cardinal point, then 315 quadrantal point, then cardinal point. So when your heading starts from 000 to 180, this is how your value of deviation is plotted. Maximum 0980 and minimum 180. Positive sine curve like this. And then as you change your heading from 180 to 360 again, from 180 it increases, 270 it reaches max, and 360 it comes down again. Simple. So this shows you max deviation east on heading 0980. And here you will say max deviation west heading 270. Another observation is 000 to 180. Easterly deviation. And here you will write 180 to 360 westerly deviation. Anyone feeling very happy clarifying these concepts? No? No one? Two students are saying yes. I like that. Others? क्या हो रहा है? अच्छा नहीं लग रहा है? जबरदस्ती मत बोलो, बोल सकते हो सर अभी नहीं, थोड़े दिन बाद में बताएंगे, या बोल सकते हो सर वीकेंड पे अच्छा लगेगा सर, वीकडेज किसको पसंद है? This is true. Write down. This is true when VSI North Pole, that is blue pole, is forward, giving a positive sine curve. Okay. Question might not come with respect to curves also. They could come to you also. So just specifying it that there. If the VSI North Pole, that is the blue pole, is aft, then we get negative sine curve. So they can ask a question like this: what if your VSI induced is aft? Then you should know the correct answers. Okay, इतना पढ़ा है तो उसके लिए भी रेडी होना चाहिए ना? नहीं चैतन्य? So just write with respect to this diagram easily 000 035. I think it should be 045, right? 045 0980 135 180 225 270. See, that's why cardinal points, quadrantal points are very important. 315 360. Or 360 is also written as 000. So if my virtual magnet or my VSI is induced aft of my compass, behind, okay, then what will happen to my headings and westerly deviations or easterly deviations? When I'm on a heading from 0 to 180, I will get max at 0980, but I'll get westerly deviation. Between heading 000 to 180, I have westerly deviation max at 90. And between 180 to 360, 80 to 360, easterly deviation max at 270. A little extra effort and your will to study a little extra has taught you 50% of the same concept in just 2 minutes. Do you understand? If you understand one concept correctly, all other variants will come to you easily. That's it. All you have to remember is 2 key points. If you focus on key points, knowledge will come to you automatically. It's like having a code for software, in putting a command key, and you get the whole detail. Good, right? It's like you need the aerodrome weather information, you tune into Datus, you get the weather information. You don't ask for entire information individually, right? Give me RVR, give me visibility, give me runway news, give me QNH. Say, request ATC information or monitor Datus. One request, multiple things. This is how we can also study. Here, when the magnetism is ahead, you will write. When the magnetism is forward, you will write max directive force is at 000 or 360, and least you could say at 180. A small reference for directive force. Just make a note of it for the sake of your questions. And here, in this case, you will write max directive force is at 180 and least at 360. When the VSI is aft, this is the case. When the VSI is front, the upper is the case. So in bracket, you can write when VSI is aft. And here you can write when VSI is forward. This VSI, don't confuse with vertical speed indicator, okay? VSI magnetism, always add magnetism, the keyword over here. Write down this point. How to fix these issues of deviation due VSI magnetism? Answer is by carrying out a procedure called compass swinging. Okay. This compass swinging is something that pilots and engineers would do whenever they think that a lot of issues are happening to my compass readings because of VSI. Okay. Write down the definition. The basic method to determine deviation. The basic method to determine deviation is to compare the aircraft's heading shown by the compass reading is to compare the aircraft's heading shown by the compass reading with the magnetic heading, which would be defined by a compass made of high quality, which would be defined by a compass made of high quality called as landing or datum compass. In bracket, you will write also called as land compass. So we have a test compass. Basically, it's a test compass used to test deviations. It will be kept somewhere else safely, and then we'll check the aircraft compass heading. So how it happens is we'll have one observer, one person sitting along with the test compass, which is called as a landing compass or a land compass or a datum compass, and one person will be sitting in the cockpit with the compass in hand. They'll have a good system where they can rotate the compass with respect to all various headings. So they'll remove the compass out of the aircraft or keep the compass in the aircraft but put it on a tripod or something like that. I've seen that happen. Okay. And then what happens is both of us, we and the person sitting with the other compass, they will say, okay, first change your heading to 045. We both will change our heading to 045 with respect to the tripod. And then we'll check what the test compass is showing me, what my compass is showing me. If there is a difference, that will the value of deviation. Easterly or westerly can be determined. Simple. Then I'll call, so we'll be connected via intercom or via mobile phones or whatever the facility is. Of course, we'll not be using pigeons. It will take a long time to get it done. Anyone getting the joke? Pigeons for messaging? And definitely will not shout also, like we'll not do that. So then we'll tell the other person, okay, now change your heading to 090. So the test compass will change 090. The test compass will be highly correct. It will not have deviation because it will not be induced by any magnetism. It will be kept in such a space or place. And then I'll turn heading of this compass to see it will be 090. Then I'll check the difference between the two, and that will be my deviation. Once this deviation is measured in all headings, cardinal points and quadrantal points, all 8 headings, then I can put this value in the compass correction card along with the cockpit, and the pilot can simply follow the same. That becomes a deviation value in a basic compass for an aircraft. Making sense now, students? What is compass swing in simple words? But it is not that easy. There are certain calculations that need to be applied to your compass readings while doing compass swing. These calculations are with respect to the different coefficients of your particular magnetism impacting the aircraft. Write down the aim of compass swing is very important point, okay? The aim of compass swing is number 1. I'm just going to dictate it, okay? Number 1, to observe or determine the deviations or differences between magnetic north, to observe or determine the deviations or differences between magnetic north observed on a landing compass, to observe or determine the deviations or differences between magnetic north observed on a landing compass and the compass north observed in the aircraft on a series of headings. So they'll put the compass in the aircraft only. And of course, you cannot. So some pilot could do it in air also, but generally it can be done on ground also. First purpose number 1, to observe or determine the deviations or differences between magnetic north as observed on the landing compass and compass north as observed in the aircraft on a series of headings. Generally, I would say these headings, generally we take cardinal and quadrantal points in sequence. Purpose number 2, to correct and to remove as much deviation as possible. How is this correction done, students? It's very exciting to know. There is a hardware related correction you can do on your compasses, basically there is a screw in a compass. That screw you can tighten or loosen to adjust for certain inbuilt deviations. Very easy function. So that you can remove as much deviation as possible. So when I will know that, let's say my landing compass is showing me exact 045 and my aircraft compass is showing me 040, even when I've changed my heading to 045, then I know deviation is 5 degrees. Then using the adjustment of the screw, I can reduce it by maybe 4 or 3 or 2. At one point, I'll not be able to reduce it. So what you see in the compass correction cards is actually residual deviation. Okay. So this second aim is with respect to that, to correct or remove as much deviation as possible. Second aim. Third aim of compass swing, write down. To record the residual deviation which is left after the compass is adjusted. चैतन्य थोड़ा मुस्कुरा दो. आज तो पहली बार 100% वीडियो मिल रहा है तो स्माइल कर लो.
Yes, sir.
परेशान है चैतन्य, परेशान हो रहे हैं. क्या हो रहा है बच्चे, तबीयत खराब है क्या?
No, sir.
कोई नहीं. बोले सर दिस इज माय स्टडी फेज, डोंट वरी, आई एम हैप्पी. आई एम लाइक ओके. First aim, second aim, third aim. Third aim, write down to record the residual deviation which is left after the compass has been adjusted during compass swing. Okay? Done, everyone. Write down note. The magnetic deviation observed during the swinging of compass is derived from hard iron and soft iron magnetism. Okay? So here you should know that if the statement similar to this point is coming in exams, then we would say the deviation will definitely be derived from hard iron and soft iron both. But earlier we saw that the hard iron magnetism is fixed and it's not going to impact our headings. But when we are doing it during compass swing, it will be impacted. Remember, these are the variations in the conceptual learning over here. Half of general navigation, I would say half of navigation is all about two different sounding similar statements which are opposite to each other. Be very careful. During a compass swing, we can say the magnetic deviation is derived from hard iron and soft iron. During a compass swing, that is the specific pointer. We're getting it right? Rohita, Sridhar, Chaitanya, Aditya. 2-3 बच्चे लोग और गायब हो गए यार. कहाँ जा रहे हैं सब लोग? If it would have been a comedy show, I would have seen that my jokes are not working because people are leaving their seats and going. But yeah, you're not my audience, you're my students. So the magnetic deviation during a compass swing can be said to be derived from hard iron and soft iron magnetism. And the total of, write down, continue, and the total of this hard iron and soft iron magnetism is further resolved into two combined components called, so I'll write hard iron plus soft iron magnetism result into magnetic deviation during compass swing. Okay. This is called total. And this total magnetism impacting my deviation is resolved into two components, I would say. Those components are called coefficient Bravo and coefficient Charlie. It is just names, everything is very easy. Note, there is one more coefficient, mathematical in nature, called coefficient alpha. Okay. Therefore, during compass swing, combination of coefficient A plus coefficient B plus coefficient C are resolved. So the effect of the hard iron and soft iron magnetism on the compass heading is resolved during the compass swing only. And that total effect is categorized under three coefficient. And the total effect is a result of hard iron and soft iron both. So A, B, and C. So now these are errors for you that are giving you magnetic deviation, which you are fixing during compass deviation. Still the compass during compass swing, and still the value of deviation will not be completely exhausted. It will be reduced. That will be your residual deviation. Okay. So write down coefficient B is the deviation caused when the VSI is along the longitudinal axis or the body of the aircraft. And coefficient C could be when the VSI is acting along the lateral axis. That is either on the right or the left wing of the aircraft. Nothing else, same. We have already studied the two. So what you have studied as forward and aft was coefficient B related deviation. And whatever will happen when the imaginary magnet is at the right or the left of the wing can be resolved into the coefficient C. So coefficient B and C are nothing but VSI induced components only. But there will be hard iron also induced, which we are not going to discuss as clearly mentioned because that is more for manufacturers. Now quickly write down the definitions. Coefficient A. Okay, definitions, you go through the text that I'll share with you all. Okay, very simple. I'm just going to give you two abbreviations. Write down this. RIMC. The abbreviation means remote indicating magnetic compass. And next abbreviation is DRMC. Direct reading magnetic compass. Okay. So this part you read, correction of coefficients and definition of coefficient you read from the text. Okay. Whatever you understand, great. Other you can skip. You have done enough for your sake of CPL exams and education. First, master this. After that, you can go in depth about compass swinging and all. Just basic introduction and reason and purpose of compass swing is something that is going to be asked, and maybe description of coefficients to you so far. What is more important for us is the accuracy or limits. For aircraft compasses. So for direct reading magnetic compass, the accuracy has to be plus or minus 10 degrees. So your deviation should not be more than 10 degrees. If it is, then you don't take that compass for your flight if you're using it as a primary flight instrument. Okay, very simple. Accuracy. Accuracy keyword, limit keyword, plus minus 10 degrees. Simple, highly scoring point. Next key point is change of magnetic latitude. You all already know the formula discussed yesterday. Tan dip is equal to Z upon H. This point we have already discussed in the beginning of class. Okay, just write down couple of points. The changes in deviation due to change of magnetic latitude is considered firstly with hard iron and then secondly with soft iron. That is vertical soft iron. Changes in deviation due to change in magnetic latitude is firstly considered with respect to hard iron magnetism and then secondly with respect to vertical soft iron magnetism. Write down for hard iron and soft iron. Just keywords are important because hard iron, these keywords have not been discussed. Soft iron will be very easy for you because we have already discussed it. It's the same thing being repeated again and again. So hard iron, you will write hard iron deviating force remains constant irrespective of change of latitude. But, okay, H, that is horizontal force, okay, not the hard iron magnetism. Horizontal force is max at poles, correction, is max at equator and zero at poles. So this has to impact our compass in some or the other way. Thus, smaller the directive force, that is H, okay, greater the maximum deviation. In bracket, you will write caused by hard iron magnetism. So again, two contradictory points. They're saying the amount of deviation is constant irrespective of change of latitude if the deviation is induced by hard iron. But because the value of H and Z change, wherever H is lower, the maximum deviation can increase the value wherever h is lower. So now this correction could be with respect to certain latitudinal positions having fixed deviation at different latitudes. Like that is the meaning. Next point you will write, hard ion deviating effect increases towards the poles and is minimum at the magnetic equator. Hard ion deviating effect increases the pole. Why? Because it's associated with H reducing, not the vertical component. So indirectly they are associating it with H, but the impact is as same as the VSI only. You see the difference in keywords, students? So write down, hard ion deviating effect increases towards the poles and is minimum at the magnetic equator, because H being minimum at the poles and max at the equator. It is related to H. Don't mark it with Z. In the option, the exam, they'll confuse you a statement where you'll think it's Z, Z, Z only, vertical only, because everywhere talk about vertical only. This is the reason I'm specifying these directly. Otherwise, even after studying so much and knowing everything, you might unnecessarily, without having your fault, because just the language and everything was so confusing, you'll end up losing a few marks. Next point you'll write, sign of deviation will be the same in both hemispheres. Sign of deviation will be same in both hemispheres. And last point you will write, max deviation due hard ion magnetism is inversely proportional to the value of H. Max deviation due hard ion magnetism is inversely proportional to H. Okay, this is my abbreviations, okay? Don't get confused. This is in-class abbreviations. You write it there in the whole sentence. Max deviation due to hard ion magnetism is inversely proportional. Max deviation is inversely, not the directive force. Inversely proportional to H. And H will change as a change of magnetic latitude, right? Now write down vertical soft ion magnetism. Write down the force. The directive force at the compass position is H, while the magnetizing force of any VSI component is Z. Write it again. The directive force at a compass position is H, while the magnetizing agent or magnetizing force for a VSI component is Z. Correct? We know this already. Next point, write down. Therefore, maximum deviation due to VSI, max deviation due to VSI will be inversely proportional to H. And you will also write the third point, max deviation due to VSI is directly proportional to Zulu. That is the vertical component. Nukul, are you following? Jyotsna, Gulshan, Suchita, Rohita, Sridhar, and Mr. Raval.
Yes.
आदित्य, तुम्हारा क्या चल रहा है?
Sir, yes, sir.
यस सर. ओके, यस का क्या समझे? ठीक है, आरटी पढ़ोगे फिर आपकी क्लास लूंगा ऐसे रिस्पॉन्सेस में. ओके, ऑलमोस्ट डन. Note, Z has no effect. Vertical component of Earth's magnetism has no effect on hard ion deviation. Remember, whatever hard ion deviations we have, Z has no effect on that. And last point you will write, max deviation produced by VSI magnetism, max deviation produced by VSI magnetism increases towards the poles. Why? Because Z increases towards the poles. Last point you'll write, max deviation varies directly with respect to tan dip angle. Very important point. Because max deviation is directly proportional to Z, inversely proportional to H, and we also know that tan theta or tan dip angle also has the same formula. Therefore, max deviation is directly proportional to tan dip. कितना कुछ है ना, अगर बेसिक स्ट्रांग हो जाते हैं तो कितना आराम से सब कुछ समझ आ जाता है, राइट? नहीं तो ये सारा पॉइंट समझने में और 3 दिन लग जाए तो भी पक्के से ना याद हो हम लोगों को. There are certain occasions when you should do compass swinging. I was saying swimming. Sorry. I don't know if compass likes swimming like I do. Compass will be like, पूरा दिन मैं काम ही करता रहता हूँ यार, मुझे भी swimming ले चलो. Will be like, compass, okay, you stand by. You are standby only. What calm? You are just sitting idle. No, no aviation jokes. Not getting it. Technical, too technical. What are the occasions? I'll just discuss with you all. You can make a quick note of it. Whenever a compass component is going to be installed or replaced, okay, a new compass is going to be installed or one is going to be replaced and a new is going to come, then we'll have to do compass swing. Second point, whenever there is a scheduled maintenance inspection for all the components, and if one of those components is magnetic, then you will have to do compass swing again. Whenever you doubt the accuracy of a compass, when you feel as a pilot, oh, I don't know if my compass is very right or wrong, so you do compass swing. Whenever there are significant or major modifications to the aircraft, including hard iron or soft iron equipments or magnetic equipments, then definitely carry out a compass swing. Okay. Whenever you are having a cargo or a payload which is electromagnetic in nature, or if is of iron, made of iron, ferromagnetic in nature, then carefully carry out the compass swing after the aircraft is loaded completely with such payloads. Okay. Whenever the aircraft has experienced some sort of shock as in some prominent force, maybe due to hard landing, due to lightning strikes, bad weather, then of course do some compass swing again. Whenever the aircraft has been struck by lightning, you will do compass swing. Whenever there is a major modification for your electrical or your radio systems, then definitely you have to do your compass swing. When aircraft is in storage, and when the aircraft is parked or stored for a long time, it will be maintaining one heading only constantly. Then also you have to carry out compass swing if you're taking an aircraft out in service after a long time. Generally, mainly because the magnetic north also is not in a constant position because of variation. And especially when the aircraft has been transported from one area to another area where there is a difference in the location with respect to their magnetic north, our magnetic north variation, then definitely you have to do compass swing. So especially if you're getting an aircraft from France or the US and getting it in India, then there will be one major compass swing happening. Definitely. This thing to change one location to another location in your textbook is given as whenever the aircraft has been given a new theater of operation. Theater of operation means area or country or state of operation, generally the country. So that sums up. Do revise carefully Earth magnetism and aircraft magnetism. After that, whenever the time is right, if you read a little bit about compass, it will be very easy to understand compass, types of compass, and the errors, acceleration and deceleration. And that finally sums up your understanding of compass and magnetism together. But going by the syllabus, what we learned, what we need to learn in depth is what we are going to cover. So we don't induce extra strain on you until your exams come. But always remember, after your exams and when you're free and you're flying, every day you can study little more extra and prepare towards giving your ATPL exams also. The extra will be ATPL. Whatever you're learning, plus that extra will be ATPL, nothing else. So anybody who wants to prepare for ATPL, you have to go through these things and learn a little extra, which is not in CPL syllabus. That is ATPL. That's the only difference, students. It's hardly 10% difference, 10 to 20% difference. So you master this and you're ready for ATPL papers also. So any questions? I'll be sharing reading notes for y'all in some time, not exactly now, in some time. Meteorology students, I'll be sending you all notes in some time. Half an hour, 1 hour, 1.5 hours to go through and revise in your meteorology time through Metar. Okay. So anybody who will need access, right now, a couple of students are learning on YouTube. So we have kept the access open. The Zoom is not working, but I'll be like giving it to y'all. Whoever needs it, let me know. I'll give access to you. It's not like you'll not get access. Okay.
Sir, I need.
हाँ हाँ मिलेगा, मेरे को मैसेज पे बताना, अभी नहीं. ठीक है, पहले ब्रेक ले लो अच्छे से. अभी टेक अ गुड ब्रेक, रिलैक्स. कंटिन्यूअसली इतना नहीं पढ़ना है, नहीं तो जितना पढ़ा है सब ऊपर से चला जाएगा हमारे. बहुत ज्यादा मेहनत कर रहे हो आप लोग. धीरे धीरे तुम्हारा मेंटल स्ट्रेंथ एंड मेंटल स्टैमिना बढ़ेगा, मेंटल स्ट्रेंथ बढ़ेगा, एंड धीरे धीरे और ज्यादा पढ़ाई होगी. अच्छे से करना है, अच्छे से अभी कर लोगे आप लोग सब कुछ, तो आपको एग्जाम पे प्रेशर नहीं आएगा. एग्जाम के लिए अभी से रेडी हो जाओगे आप लोग. तो हर एक टॉपिक ऐसे पढ़ना है कि मैं अभी से ये टॉपिक एग्जाम के लिए कर रही हूँ या कर रहा हूँ. समझ रहे हो स्टूडेंट्स? बाद में के लिए मत रखना, नहीं तो 19-20 हो जाएगा. तो इतना सब करके अच्छे से भी हमको 65-68 आएंगे तो क्या फायदा है फिर. हमें क्या चाहिए? हमें 80, 85, 90 चाहिए. ध्यान रखना उसको. तो आप अपना टारगेट सेट कर लो. नेक्स्ट सेशन में मुझे अपना टारगेट मैसेज करना आप लोग, मैं पूछूंगा तब 90 है कि 95 है कि 96 है कि 85 है. मैं तो बोलूंगा 90 के ऊपर ही टारगेट रखो. कोई बच्चा बोल रहा है 100%, तो मुझे अच्छा ही लगेगा, बुरा नहीं लगेगा. बट उस हिसाब से हमें ज्यादा पढ़ाई करनी होगी, ऐसे सोचना है. दिमाग को बोल देना. नहीं तो मैंने देखा है ये गुड स्टूडेंट्स ऑल्सो फेस दिस प्रॉब्लम. जहाँ उनको पता होता है 70 है ना, वो एक आध सिलेबस लास्ट में छोड़ देता है. और कभी कभी है ना, ज्यादा क्वेश्चंस वहां से ही आते हैं जहां से हमने छोड़ दिए, और जो पढ़ के गए वहां से कम आते हैं. तो हमारा सेफ्टी ब्रैकेट 80% का खराब हो जाता है, और हम 65-68 आ जाते हैं फिर. जबकि बच्चे को सब पता होता है, बट एंड में वो टाइम नहीं मिला होता रिवीजन का, जहाँ वो हमें सिलेबस छोड़ना पड़ता है फिर. तो आप वो स्ट्रैटेजी नहीं यूज करोगे. आप ट्राई करोगे जो स्ट्रैटेजी मैं आपको दे रहा हूँ वो यूज करने की. पढ़ाई तो हो ही रही है, नॉलेज आ ही रही है, रिवीजन हो ही रहे हैं, पर एग्जाम भी तो क्लियर करनी है ना हमें. उसके बिना तो क्या ही मतलब है. वो तो मेन पर्पस है तुम्हारा और मेरा. नॉलेज भी मेन पर्पस है. आज नॉलेज आ गई, उसको दिमाग में परमानेंट बनाने के लिए आप लोग रिवीजन करोगे, डाउट्स पूछोगे, सेल्फ स्टडी करोगे, एग्जाम्स क्लियर करोगे. ये तीनों हमारे प्राइमरी गोल्स हैं. गोल वो अचीव करना है, ये पाथ है हमारा जो हम वॉक कर रहे हैं. समझ रहे हो? कोई भी गोल के लिए कोई भी पाथ इजी नहीं होता स्टूडेंट्स, सबको पता है ये चीज. पेरेंट्स को पूछ लो, आपको खुद को पता है. करेक्ट. कहीं पहुंचना भी होता है हमें, भले ही हमारी प्लेन हमें 1-1.5 घंटे में दिल्ली पहुंचा देती है, बट क्या 1-1.5 घंटा ही लगता है घर से निकलने से डेस्टिनेशन तक पहुंचने के लिए? घर से एयरपोर्ट पहुंचना होता है, एयरपोर्ट के अंदर कितनी बड़ी जर्नी होती है, कितने चेक्स होते हैं, फिर एयरपोर्ट से निकलते हैं वहां चेक्स होते हैं, फिर वहां से वापस कहीं जाना होता है. जर्नी इज ऑलवेज डिफिकल्ट. बट वो डिफिकल्ट नहीं है, लेंदी हो सकती है, शॉर्ट हो सकती है, कॉम्प्लिकेटेड हो सकती है. उसको उस हिसाब से आप ट्रैवल करोगे तो कभी डिफिकल्टी नहीं आएगी हमें. तो अपना माइंडसेट क्लियर रखना है. कुछ चीजें जो कॉम्प्लिकेटेड है, डिफिकल्ट नहीं है, उसको थोड़ा ज्यादा टाइम देना है, ऐसे सोचना है. इवेंचुअली यू विल गेट इट. आगे बात समझो. आई हैव नेवर सीन अ पर्सन हु वांटेड टू बिकम अ पायलट एंड वाज नॉट अ पायलट. आ रही है बात समझ में? वो तभी होता है जब उन्होंने गिव अप कर दिया होता है, चलो आज मुझे पायलट नहीं बनना, अब मैं कुछ और करने वाला हूँ। बस वही लोग हैं जो नहीं बने हैं पायलट, जो बाय चॉइस छोड़ देते हैं फॉर एनी रीजन, गुड और बैड। अदरवाइज एवरीबडी हु वांटेड टू बी इज अ पायलट ना, कोई जल्दी कोई लेट एज अ वर्किंग पायलट, बस इतना ही डिफरेंस होता है। कोई किसी को 30s में जॉब लगती है, किसी को 20s में लग जाती है, किसी को मिड 20s, किसी को लेट 20s, किसी को अर्ली 30s, मिड 30s में भी लगती है, कई लोगों को लेट 30s में भी मिल सकता है। डिपेंड करता है, कितनी सारी अपॉर्चुनिटीज है हमारे पास, है ना? चलो, आई सी यू। थैंक यू फॉर बीइंग अ नाइस क्लास। तुम्हें कभी भी एक सरप्राइज टेस्ट आ सकता है। जब भी टेस्ट आएगा, गूगल फॉर्म्स एंड ऑल, कॉपी मत करना, ऑनेस्टली करके सबमिट करना, चेक करना है। उसके बेसिस पे मुझे पता चलेगा, चलो ये तुम्हारा जो बिहेवियर है ना डाउट्स पूछने का, साइलेंट रहने का, वैसे डाउट्स नहीं है तो नहीं पूछना। आई गेट टू नो दैट वर्क कर रहा है कि नहीं कर रहा है। नहीं तो फिर थोड़े और रूल्स एंड रेगुलेशंस लगाएंगे ताकि आपको ही ज़्यादा फायदा हो। That being said, if you have any challenges, problems, or requests, just leave me a message so that I get the weekend's time to work on it and then deliver from next week. Next week, के live lecture schedules will be sent out to you all. If you have any request, any concerns, drop me a message. I'll try to work around it before I develop the schedule so that everybody can benefit from the schedule. Okay? चलो, I'll take your leave, students, if you allow me. आप लोग ना नहीं बोलोगे तो मतलब आप अलाउ कर रहे हो। Okay, thank you. You too have a good day, and I'll see you when I see you. Bye, everyone.
Thank you, sir.
Bye,
Most
sir.
welcome.
Thank you,
Thank
sir.
you,
Bye,
sir.
sir.
Most welcome.
Thank you, sir.